Okay, on problem number 30, sketch the graph of the rational function. Identify all asymptotes, intercepts, and holes. So we need to factor this thing in order to be able to sketch its graph. That denominator there, let's factor out the 3. We'll get an x minus 1. Let's factor that quadratic. X squared minus 3x minus 10 means x minus 5 and an x plus 2. That numerator is a difference of nada. It is a fourth degree function. We don't know any solutions, so we should probably try factoring by grouping. So when you're factoring by grouping, focus on two sets of two terms clumped together. I clump the first two terms because they both have 2's. I clump the last two terms because they both have 32's. So if I look at my first clump of numbers, what do they have in common? They both have a 2x squared. So pull a 2x squared out. What is left behind? Put it in parentheses. 2x squared times what is 2x cubed? 2x squared times x is 2x cubed. 2x squared times what is negative 2x squared? It's got to be a negative 1. Okay? Then what? Minus 32x plus 32. Let's pull out a minus 32. What's left behind? Minus 32 times x is minus 32x, and minus 32 times negative 1 is positive 32. This is good because both of these terms have an x minus 1 in them, which means I factor out that x minus 1, and I put what remains in parentheses. 2x squared minus 32. So I have that right there. Notice 2x squared minus 32 can be factored further. I can pull out the 2, so I have x minus 1 times x squared minus 16. And now hopefully I see 2 times x minus 1 times x minus 4 times x plus 4. A difference of squares. That is all over this denominator that I have already factored right there. And look, we have x minus 1 over x minus 1. We have a whole that is going to need to be removed. So let's remove it, and what will we have? We will have 2 times x minus 4 times x plus 4 over 3 times x minus 5 times x plus 2. So, what do we do from here? We need to identify some things. Let's remind ourselves that x cannot equal 1 because of that whole. So let's identify stuff. The whole will be at positive 1. And what's the y value of the whole? Well, how do you find it? You plug in the x value after you remove the whole. So if we plug in the x value, what do we get? We get 2 times 1 minus 4 is negative 3 times 1 plus 4 is 5 over 3 times 1 minus 5 is minus 4 over 1 plus 2 is 3. So if I'm simplifying this without a calculator, I first notice I have two negatives making me positive. Then I see that I have a 3 on top and a 3 in the bottom, so I cancel that out. Then I see I have a 2 on top and a 4 on the bottom, which means 2 over 4 is the same as leaving 1 power of 2 in the bottom. So I have 5 over 3 times 2 tells me that my whole is at 1, 5 sixths. As long as you find your whole first, it doesn't matter what you find next. So how about we find our x-intercepts next? In my numerator, I have x minus 4, x plus 4, which tells me I will have x-intercepts at positive 4 and negative 4. So write them as points, because that's what they are. So 4, 0, and negative 4, 0 are my x-intercepts. Let's do our y-intercept. It says to find the intercepts, that means x and y. Y-intercept happens when x is 0, so we need to plug in 0 and see what we get. So 2 times 0 minus 4 is negative 4 over 0 plus 4 is positive 4 over 3 times 0 minus 5 is negative 5 times 0 plus 2 is positive 2. So not much simplifies, but I got the 2's canceling and I've got a double negative. So I'm left with 4 times 4 is 16 in the numerator divided by 3 times 5 is 15 in the denominator. So I get my y-intercept. What about my vertical asymptotes? So my vertical asymptotes will happen when the denominator is equal to 0. So I have two factors down there. X minus 5 tells me a vertical asymptote will happen at x equals 5. And another one will occur from the x plus 2 factor, telling me x minus equals minus 2 is another vertical asymptote. The last thing I need is my horizontal asymptote. Degree of the numerator is 2, degree of the denominator is 2, therefore my horizontal asymptote will occur at the value of my coefficients, which is 2/3, so y equals 2/3 is the equation of my horizontal asymptote. Let us sketch all of this information in. It's a lot. So, let's see. What do I need? X value wise, I need 1, 2, 3, 4, 5. 1, 2, 3, 4. What do I need y wise? I need to show a 2/3, so let's give ourselves a 1. Let's go ahead and dash in that asymptote at 2/3. Boom, 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 right there. So that's good. Vertical asymptote's at 5, so we can dash that in right there. So that's good. -2, so we'll dash that in. So that's good. Y-intercept 0 and 16/15 means it's a little bit above 1. So we'll put that in right there. X-intercept's at 4 and -4 right there. And a hole at 1, 5/6. So 1 and then right there. A little bit above that asymptote should be where we're at. So because all those points and things we have marked, this shape is already defined, so hopefully it doesn't take you much work to see that it has to look like that. It has to come through and connect all these points in the appropriate way. And I know that there has to be up because I don't have any x-intercepts and I have a positive horizontal asymptote. So my graph should look like that. I really, really like graphing rational functions. I think it's really fun.